So what we're going to have a look at in this tutorial is how to create mold tools from your parts in Solidworks. So I've provided this part. This is Molded Cover 02. If you'd like to download that and load it into Solidworks, as you can see, it's a typical molded part. It has a thin outer wall, it has some faces missing, it has some rib features. It has draft angle on most of these surfaces to allow easy removal from the mold, and it has these through cuts. So it has 3 cuts or cut features that go all the way through the finished part. So that's the part that we're hoping to mold, and just to familiarize ourselves with some of the terms and the process. I've already completed the mold for this particular part. So if we have a look here, I'm in a new part here. This is the part that I use to create the mold tool. So if I click on one of the bodies in here and just isolate it, just so that we can see what we've created. So that is the top half of the mold. This would be known as the cavity. Because if you imagine this as a solid block of material to begin with, and then some material is machined away to create kind of an indent into the main block of material. So that is why it's known as the cavity. It's a cavity down into a solid block of material. So that's the top half of our mold. And then if we isolate the bottom half now, that is what the bottom half of the mold looks like. So you can see the negative shape of the ribs. So that is where the rib features end up. So we've got the negative of the rib features in this bottom half of the mold. So this is how you kind of build your molds inside Solidworks. You import the finished part into a new empty part, and then you create a parting line. So that's what the blue line is here, that represents where the split will be in your particular molding setup. So if I hide some of the parts here and show the original shape of our finished part, so that is the shape of the finished part as it's been designed. That gets imported into our molding setup. We mark out where the 2 halves of the mold are going to split away from each other, so that is the parting line. Then from the parting line we create something called a parting surface. So you can see that surface comes outwards from the parting line in all directions. And that surface allows us to define where the 2 halves of our mold split from each other. So if you imagine this upper block, this kind of brown block, and this blue block start life as one complete block, and this parting surface is used to chop those 2 halves into 2 separate blocks, so that you can make a mold that has a cavity. So if you remember, this was the cavity, that's the cavity half of the mold, and a core. So this is the core half of the mold. So yeah, that's broadly the process. And in terms of the workflow, we import the shape of our finished part into a new empty part. Then we create the parting line. Then there's a little intermediate step that you will not always have to use, but on this design we will have to use it, because we have a finished part that has holes that go all the way through the part. So that little intermediate step is shut off surfaces. Then we'll create our parting surface, which is what this big surface here is. Then we'll create our tooling block and split it into 2, and then we'll eventually save out the 2 halves of our mold as separate parts, so that we can then pass them on to the machinist to actually make the two halves of the mould. So we'll save out this shape and we'll save out this shape into their own separate part files. So that's the broad kind of workflow that we're going to follow. So I'm going to close this finished mold tool down because we're going to recreate that now. So I have my finished part on the screen, and from this point I'm going to create a new part file. So I'm going to go File, New Part. Then I have my empty new part, and the first thing I'm going to do here is I'm going to say insert another part into this part. And because I have my molded cover 02 already open in Solidworks, it gets listed here, and you can see it following my pointer around. So I've got the option of importing various different things from inside this part. All I want really are the solid shapes or solid bodies within that part. I don't want any surface bodies, I don't want any planes, I don't want the part material, I don't want the body material. I literally just want the outside solid shape of that part itself, because that is gonna be my cutting tool to cut away that shape from inside the mold tools. So that is what's going to form the actual mold. So I only want solid bodies, so then I'm going to click on tick. So there's a copy of my finished part actually inserted into this new part. If we have a little browse as to what that looks like in the feature manager, there are no features imported. So this is why we do it this way, because I cannot now inadvertently make a change to this part. The part is secure, it's stored in a separate file. If I do want to make a change to the design, I will go back to this original file and I will change something. Let's just, for the sake of argument, see what happens when we change the radius of this fillet. So let's see if we can go down to 2 millimeters with this radius. Yes, so that's worked. So that's how we would make a change if we wanted to. And then when we go into our imported part, it updates to incorporate that change. But we can't affect the part from this end. So I'm trying to click on that fillet to edit it here. I don't have the option. So this is a one-way link. We can only make changes to the mold tool by going back into the original part and changing it. So this is a one-way link, which is the safest way of setting our mold tools up. So back into my new part. So I've imported my mold tool. So generally speaking, as I said earlier, we're going to work from this icon to the right. So we're going to press this icon first, then we're going to move on to this one, then this one, then this one, possibly this one, and possibly this one. So we work from right to left. But before we begin any of that, what you undoubtedly will need to do with most molding materials, so this holds true for the majority of polymers or plastics that you might use in your mold, that polymer or plastic will have a shrinkage value associated with it. So when it solidifies, it shrinks slightly by a percentage. So let's put a typical shrinkage value onto this shape first. So the way that we do that is we click on the scale icon. And if you think about the logic here, if our part, as it gets injected into the mold and then begins solidifying, begins cooling, gets smaller, then our mold needs to begin bigger in order to account for that shrinkage that the part will experience. So we make a mold which is slightly bigger than the finished part size that we require. So what I'm going to do, I'm going to imagine that I have a shrinkage value of 2%. How would I account for that at this stage? Well, I'd go, the logic here is that 1 which is the current scale that we're looking at this part, represents 100%. So if I had a shrinkage value of 2%, I would scale this mould to 1.02. That represents 102% essentially. So 1.02 accounts for a shrinkage value of 2%. Now you will have to find the typical shrinkage values of whatever materials you're going to use, but that's typical of some polymers, 2% shrinkage. So when I click on OK here, my part will scale up slightly by 2%. The only other thing that we may want to think about changing is where the part will scale about. So where will be the center point of this scaling operation? Will it be the origin? So if we just show the part origin, if we can. There it is. So you can see it appearing. It's that little orange dot there. So do we want to do our scale operation around the origin, or the centroid is essentially the center of mass of the part itself? It doesn't really matter for us in this instance, although I think the origin is kind of a more logical place, because you can quantify where that is in the world. It's right there. So it's that orange dot that appears there. So we can put a location as to where the scaling is occurring around, whereas the centroid will change depending on the shape of our part itself. So I prefer to use origin. So if you watch the part, when I click on the green tick, it will get slightly bigger. There. So it's scaled up by 2%, which, as I've said, the logic of that is that the cavity inside our mould will be 2% bigger than the part size that we require, and that accounts for the 2% shrinkage that we will see. So we've done that. We've done the scale operation. Then we have to do something that we don't see the benefit of initially, but we have to do it when we're creating a mould. So we insert mould folders. Again, nothing appears to happen, but it will become obvious what that did when we begin on this next feature. So parting line is what I'm going to address now. So the first input that the setup of this parting line requires from us is the direction of pull. So this is the direction that the two halves of mould will have to move away from each other to open, to let the finished moulded part out. So in terms of how we're looking at our part here, it's up and down, or the y-axis, if you want to relate it back to the coordinate system down here. So we need some reference to tell the system that the halves of the mould are moving up and down. So if we have a look in our part setup, that would be the top plane. So the top plane, normal to the top plane, is up and down essentially. So we'll click on the top plane, and then we'll click on draft analysis. And what the system does, it looks at the geometry that we've given it inside our part, and it also takes into account the split plane, or the direction of pull that we've given it. And essentially what it's done is it's viewed the part from above or from below. It doesn't really matter, but it's traced the outside shape that it sees from that viewpoint. So this is often known as the silhouette curve, or the parting line or parting curve. So this represents the outside shape of the part itself. And as you can see with this part, because of the way I've designed it with appropriate draft angles where they're needed, it can fully automatically trace the outside shape of our part. Now in certain circumstances where your part geometry maybe is not drafted correctly, or you've got a particularly complicated part, it can come up with a partial parting line, which is what I've trimmed this parting line back to be. So if you don't see a complete purple continuous line that meets itself like I've got now, what you can do is you can manually add edges to the parting line. So if I want to add this edge, I can click on the edge, and then if I want to add this edge, I can click on the edge. And this arrow here, if I want to get other options, so maybe I don't want to add this edge, so I click on the arrowhead, it's saying, well, maybe you'd want to add this edge, possibly. So every crossroads or every T-junction along this curve, if it meets other curves or other lines or other edges, I get the option of either going in this direction, or if I click on the arrowhead, going in this direction. So it's giving me options there. But if I can see the clear path to close the curve, I can just click and click and click. So I've gone the wrong way there, that's okay. Zoom in a bit, click, click, and then I've got a complete parting line then. So what we're looking to create is a complete loop of edges, essentially. So when we've done that, we can click on the green tick. So there's our parting curve, or parting line. So now, this was the option that I said you won't always have to address this. Sometimes you can skip this next step, this shut-off surfaces. So you'll need to create these shut-off surfaces if, like this part, there are holes in your part that pass all the way through, from the one surface of the part all the way through to the other surface of the part. So this is when you will have to create shut-off surfaces. So in my case, I'm going to click on shut off surfaces. Again, it analyzes my part geometry and it makes some suggestions about where I would want to place the shut off curves. So these are essentially the ends of the so if we just cancel this momentarily, and I'll call up one of the halves of our mold tool. So there's my finished mold tool from earlier on. So what are we creating here? We're essentially creating the end faces of these three little protrusions here. So that's what we're hoping to create. That is a shut-off surface. There's a shut-off surface, there's another shut-off surface, and there's another shut-off surface. So we're trying to create those. If you want to think of them, they shut off the path for the plastic, so the plastic cannot flow through these areas. So these three highlighted faces touch the other side of the mold tool. When the two mold tools come together, these three surfaces touch the other half of the mold, so the plastic cannot flow through here. So you end up with a hole. Wherever the plastic can't flow through, there's a hole through the part. So we're trying to create these three blue surfaces. So if we keep that in mind and then go back into our part, so what we essentially want to do is cap the bottom edges of these three holes. So that edge there, and the bottom edges, all four of them, of that slot shape, with a surface which is going to form the end surfaces that we were just looking at in the top half of our mold. So let's do that. Let's select shut off surfaces. I'm going to turn the preview on as well, and I'm going to delete all these surfaces that it's automatically found for me. So I'm going to right click in here and say clear, and the first edge that I'm going to select is the edge at the bottom of this hole here. So, and then I get a preview of what that surface will look like. Then I'm going to do the same thing here, click, then I get a preview of what that edge will look like. Then I'm going to click here, and what this arrow is offering to do is just continue my edge selection, and the way that you do that is press the Y key. So press the Y key, and then press the Y key again, and then press the Y key again. So that's what I've created. And we can leave these patches set to, or these surfaces set to contact, but if we want a kind of smoother surface, we'll set them to tangent. So tangent, tangent and tangent. So we've created our shut-off surfaces, so we can move on to the next option, or the next menu item. Just before we do that, back at near the start when we clicked on Insert Mold Folders, what that did for us is it allowed us to more easily track what things we've created and where they're stored. So I've opened up the Surface Bodies folder, and within the Surface Bodies folder, when we clicked Insert Mold Folders, it inserts some subfolders inside there. One is for cavity surface bodies, so if we have a look in there, the shut-off surfaces live in there. If you just want to view the shut-off surfaces, you can right-click and say Isolate. So those are the shut-off surfaces. And then you click on Exit Isolate to get out of there. If you just want to have a look at the core surface bodies, you can isolate those. So those are the core surface bodies. And then Exit Isolate. So it's organising our various mould surfaces into subfolders that are easy to find. So it's doing a little bit of kind of organisation for us. So that's why it's good to always click on the Insert Mould Folders, just to keep your feature tree neat and tidy. So let's keep going. Let's create our parting surface. What this does is it uses the parting line that we created, so that blue line, and it extends outwards from there a surface which is perpendicular to the pull. So if you remember, the pull direction is up and down for our mould. So the parting surface goes in kind of a horizontal away from the parting line. So I'm going to make a parting surface in this case which is 45 millimeters long, or 45 millimeters extended from the parting line. So what value is sensible here? A value which is big enough to go beyond the edges of your mould tool. So don't get too obsessive with this. You can always come back in and edit this value later on if it's not quite big enough. So 45 is reasonable for this particular setup. If you imagine my mould tool, so I'll look down from above, my mould tool will be something kind of here. So my mould tool will probably be within the boundary of the parting surface, the outer edge of it. But as I say, you don't need to be too worried about that. You can always edit the value later on. And then everything else I'm just going to leave on the default settings. So I'm just going to click on OK. So there's my parting surface. So we've tackled parting surfaces. So again, we're moving along these icons one by one. So tooling split is the next icon along. So what I have to do now, I have to draw the outer shape of the mould itself. And if you remember, our shape was kind of a cuboid, its outer shape. I don't think it was quite a square perimeter. I think it was a rectangular perimeter. But I need a plane to create that sketch on. So let's pick one of our primary planes, the top plane. So I want to look down from above, and I want to sketch out, I want to create a sketch of the outside shape of our mould, this rectangular shape. So I'm going to click on the top plane. My view then rotates round, so I'm looking directly down at the part, and I'm just going to use the center rectangle and create a rectangle that goes beyond the outside of my my part. So how far outside? I would say a minimum of 10 millimeters beyond your part. So if you want to relate it back to your part, you can pick one of the furthest edges out from your part and say, so I said a minimum of 10. I'm actually going to go for maybe 20. No, let's reduce that down a little bit. Let's go for 15. Yeah, that looks okay. And rather than put a 15 over here, what I'm going to do is I'm going to get the center of this rectangle, and I'm going to make it vertical to the origin there. So I lock those two vertically so that whatever this value changes to, the value on the other side follows along. So then I'm going to do a similar thing on the back of my part here if I can. I'll just find a little point there. So I'll put 15 millimeters there to begin with, and then I'll do something similar at the front here if I can. So it's trying to find the center of that arc. So as we saw in previous lessons, if you want to dimension to the actual surface of an arc itself, firstly I'm going to click on this line, then I'm going to hold the shift key down, and then I'm going to click on the arc. So that allows me to actually dimension to the actual outer surface of that arc itself. And I'll probably set that to 15. So you can see here I've gone beyond my surface, my extended surface there, so that's not good. So I'm just going to squeeze this dimension back in a little bit, and then maybe I'll go back and edit that surface, and then I'll come back in here and kind of extend this outwards again. So that's okay. So I'm within the surface that I created, and I'm outside the finished shape of my part. So that's all I need. So I'm going to click on OK, and then I'm going to rotate my view round so I can kind of appreciate what's happening here. So what is happening? From that sketch that we created there, we're extending mold material both upwards, as we're looking at it, and downwards, to fully encompass the shape of our part. So how far am I going to go upwards in this case? Well, at least to there, I would think. So you need to leave some mold material outside of the finished part just to give the mold rigidity, and if you're planning on putting any cooling channels through the mold to pump water through to try and cool the mold tool down, then you need extra material to accommodate them. So the top of the mold there is okay for the time being. The bottom of the mold is kind of offset from the part by a similar amount. Maybe we'll go a little bit further. So let's round these to more sensible numbers. So 64 upwards, or 65 just to be a bit more sensible, and 15. That is fine for our purposes for our first mold. So click on OK, and then we've got our 2 blocks of material. So what has the system done for us now? Well, it's added some more bodies. It's added the parting surface in the surface bodies folder there, and it's added 2 new solid bodies as well. So it's added a body which it's named tooling split 1 brackets 1 and tooling split 1 brackets 2. So these are the core and cavity shapes for our mold. So if we go through and hide everything else and then just inspect what we've ended up with. So the easy way to show and hide things is to open up this pane at the side of the feature manager there, and then if you click on these icons, that hides whatever you click on. So I'm hiding everything except these 2 parts, and then I'll hide these one by one. So I'll hide this one first, and then I'll inspect what I've created. So that's the upper portion of my mold finished, and then if I hide that and show the other tooling split 1 1, this is the lower portion of my mold. So I've created the 2 halves of my mold now. So there they are. And then in the example earlier, all I did was, just for clarity, I right clicked on one of these halves of the mold and went into appearances and just set the appearance of this body slightly differently to the other one. So just give it a slightly different colour, so it's easy to tell them apart now. You don't need to do that step, it's just it makes it more obvious which one is which. So when you get to that point, it's probably wise to save all that. So save all, And then what did I call this originally? I originally called the one that we were looking at earlier Mold Tools Setup. So maybe I'll call this Mold Tools Setup B, just to differentiate it from the original. So that's that saved, Mold Tools Setup B. And what do I want to do next with this? Well, what I want to do ultimately is I want to use this assembly to save out the two halves of the mold as separate parts. So how do I do that? Well, I need to select which half of the mold I want to save out. So I'm going to save out tooling split 1 first in solid bodies. So I'll right click on that and I'll say insert into a new part, and then I'm just going to click on OK. Now you may get this warning that the units template that my original part was made using is different to the one that is now going to be created. You can answer yes or no. I'm going to answer no. It doesn't really affect things too much. And then it tries to automatically generate a name for this new part. So it's given it the name of the assembly that I just defined. So Mold Tools Setup -B was the name of the assembly, and then it's just added tooling split 1 to the end of it. So I'm happy with that. I could change that to which half of the mold is this? It's the core. So this is not the cavity, this is the core. So maybe I could replace the word tooling split 1 with core if I wanted to. It's entirely up to you. Yes, I think I'll do that in this case. It makes it a bit easier to understand which is which. So Mold Tool Setup B, this is the core half of the mold. So save. So this is now its own part. So I could take this through into a CNC machining plugin for Solidworks, and I could write some CNC machining code to actually machine this from a block of material. So I can shut that down. I don't need that open. I'll say save all just before I shut it down. And then I'm going to do the same thing with the other half of the mold. So this half of the mold. So I'm going to right click on it. I'm going to say insert into a new part. I don't want to change any of the options here, so I'll just click on OK. I get the warning saying the units used in the creation of the original part are different to the one that you're about to create. Do you want to convert? No is the answer. And then I can give this a similar name, except this time it's going to be cavity. So this has been saved as Mold Tool Setup B, which is the name of the assembly that created it, and cavity. So the beauty of all of this now is that there is a link, a one-way link, all the way from the original part through the molding setup that we created, so through this file, all the way into the two core and cavity files that we've created. And I'm going to illustrate that link now. So I'm going to change something about the design of the part. So I'm going to go back into molded cover. Maybe I'll change the diameter of these holes. So if I click on the holes, let's try clicking on them. Yeah, double click on them. The diameter of them is currently set to 8. So maybe I will shrink that down. Maybe we'll go down to 4 millimeters and then rebuild. So now the part has been changed. And because the other two files are still open, if I now go into them, so I'm going into the mold assembly. It's not technically an assembly, it's a part. But if I now have a quick look to see, has this mold updated? Yes, it has. So you can see there, these little kind of protrusions that stick out of this half of the mold have shrunk down because I made the change in the original part. And then if I go into the cavity, yes, so those changes flow all the way from the original part through our molding setup here, all the way into the final exported part here, which we could use for the basis of our CNC machining. But we can't send any changes the other way, which is arguably the safest way to set this process up. So the changes can only flow from the original part downstream towards the mold tools. And obviously that link only works if all the files are open. It only happens in real time if you have the original open, and then you have the molding setup open, and then you have the final exported part open as well. If not, you will have to do a refresh, and it will ask you, do you want me to check if any of the original files that created these other files have been updated, and you'll have to manually agree to that. Whereas if you get everything open within Solidworks, you can make changes in real time, and they will carry through into all the mold tools. So just to finish things up here, I think I said earlier I was going to extend the parting surface slightly. So if I just double click on that, I can see the value that I extended it by. I'm going to go a little bit further, just so that I can increase the size of this block if I require it. So where's the sketch that controls that? There it is. So that 8mm at the front can now be extended outwards to 15 to match all the other sections of the mold. And then what I could do if I was genuinely creating this mold, I could create things such as clamping holes to hold the two halves of the mold together. So I could do that easily within this part now. I could just sketch on the top surface here, create a circular sketch like so, dimension where that sketch was from the edges of the part like so, and then just do an extruded cut and say through all like so. And that will cut through both halves of the mold. Now what I'd likely do if I was creating clamping holes for this mold is I'd put holes in each corner. So maybe I could put a center line in here at the midpoint there, and then I could say mirror entities, mirror that hole about that center line. Now it's interfering with the part now, so I'm going to have to make some changes, but I'll accept that for the time being, and then I'll go back in to my tooling split sketch, and I'll increase the amount of material at the back edge there. There we go. So now I've missed my finished molded part, which is obviously what you would like to do. So then these two holes can be mirrored over to this side. So if we get the right plane and say mirror, features to mirror, this hole, that will get mirrored across to the other side of the mold tools there. So then if I want to just inspect one of these halves of mold tools, I can hide one of them so I can see where the holes are. Now this is not ideal. This surface is part of the parting surface that we created. It's not part of the finished molded shape. That begins here. So here and here and here and here and here is the finished molded item. But this is not ideal to have a hole through there. So maybe we would want to increase the size of our part in our mold in this direction as well, and it would push those clamping holes further out. So that's arguably a better kind of design. So let's check the other half of mold. Yeah, again we're quite close to this edge here, so it may be worth adding a little bit more of material. So that's how you might create some clamping holes to clamp the two halves of the mold together. If you run your Solidworks plastics analysis, you can then define where the injection point is for your mold tool. So let's imagine there is an injection point somewhere. Let's imagine it's on the bottom surface, which is more likely. So if we could create a sketch and cut straight through to the mold. In fact, let's try that. So let's put an injection point somewhere here. Let's have a 4mm injection point. Make sure that it's central, and then dimension it relative to the origin, let's say. So let's imagine we had run Solidworks plastics and that was our injection location. Well, what would we do? We'd do an extruded cut, but instead of going through all so that it breaks through the top surface of the mold as well, we just go through to next, and then we'd inspect that we'd created what we expected to there. So no, it's come all the way through there. So what we're going to have to do is hide the top half of the mold there. It's because we've hit one of the rib features, so that's an unlikely position to actually put that injection location. So if I move it forward slightly so it's entering the mold at a more sensible location, yes, that is better. And all we would do, we would say, instead of through to next, we would say, well, let's try that again, through to next. There we go. And then it doesn't cut into the top half of the mold, because obviously you want the plastic injected through one half of the mold. You don't want it to just exit the top half without having filled the cavity in the middle there. So you can gradually build up the required features on your mold, of which clamping holes and injection locations are two. Another one, which as I spoke about earlier, are cooling channels through the mold. So in order to add cooling channels to this mold design, maybe we would need some more material down at the bottom here, maybe some more at the top. And the cooling channels could just be holes that pass through either from this face all the way through, or from maybe the back face all the way through. Obviously you would have to ensure that they do not interfere with the clamping holes, because otherwise you would get water pouring out of the clamping locations. So I'd encourage you to kind of read about mold design, what sort of features you need to include in a mold design, such as clamping holes, cooling channels, injection locations, all these sorts of common features. But you can add them into this setup just by ensuring you have enough material and then creating the required features. If you need to cut material away, you can use extruded cuts, very easy to set up. Yeah, and you can add those features in, and then when you add them, they end up being shown on the parts that you've saved out. So you can see them here. They've been brought through into this cavity part that I saved out. And likewise, if I open up the core, there's the core. The system realizes that something has changed since the last time I opened the core. So it's saying, do you want me to rebuild? And there you go. So the clamping holes and the injection hole have been included in the core part now. So yeah, that's kind of the broad outline of how the mold tools work within Solidworks.